back, everyone. Today we are talking about converting a recipe to an industrial formulation. And I often think about examples. If we were together in class, we would often do some basic recipes. I often, in the nutrition class that this lecture is accompanying, would make the students make a smoothie. Why? Because a smoothie is something that you often make at home, and you might have a recipe. You might be improvising, but a smoothie is also something that could be made at a food service outlet. Some of the places like Booster Juice or whatever are making smoothies in larger quantity, and they want to have that smoothie repeatable. Or maybe you're working at a company like Lassonde or Greenhouse Juices and making smoothies in tens of thousands of liters, and you need to have that smoothie repeatable every single time. Well, as a product developer, you need to be able to really think about making that product initially at the bench scale, and then scaling it up to a larger pilot run, and then scaling it up to a large industrial formulation, such that you can make that product time and time again. But it all starts at the bench, and that all starts with being able to document things properly. And so today we're going to talk about converting recipes into industrial formulations and some of the basic good practices that you should be implementing. So at the end of this video, you will be able to define some core rules for converting a recipe to a formula. And you'll note I use those words deliberately. A recipe implies that it's meant for a food service outlet or for a chef or for a home consumer. And a formula is what we use in the manufacturing sector. We'll use a basic formulation spreadsheet for tracking costs per gram. We'll use a basic formulation spreadsheet for converting classic household measures to weights and percents. And we'll define opportunities where yield calculations must be used to accurately represent the final product. So, first off, I think this video is actually going to end up being a two-part video because there's a lot of content here. But let's walk through some basics about good best practices. Again, if we were making that smoothie together, I would be asking the students to put the pitcher of the blender on the top of that scale and then weigh out everything that they were putting into that smoothie. So if, let's say it was a banana smoothie, I think my example in the next one's a banana milkshake. So we've got a banana going in there, maybe we've got 75 grams of banana, and we've got a cup of milk going in there, so maybe 250 grams of milk. Maybe we've got some vanilla extract or some honey going in there. We need to weigh everything out accurately and ideally on a calibrated scale. And so I realized that in your class you may have the scale that you got in your gear bag when you join the college. Ideally, as you are progressing in your career, you're going to get a calibrated scale. I realize right now with COVID, you may be doing some assignments at home using your scale, and we'll deal with that. But get a calibrated scale, and that means that there's a certificate that's accompanying it to prove that scale is accurate, and you can send that scale out for recalibration on a routine basis. It's not a $20 Canadian Tire scale. It's usually going to be in the several $100 range. You do want to learn some tricks to make your weighing easier. So, for example, think about the unit operations that you need to do when executing that recipe. Can you take the bowl or pot that you're working with directly and weigh directly into that working vessel? I put this image here of honey in a measuring cup because you can think about if you're putting it into a measuring vessel and then having to transfer it out, you're going to have yield loss. Think about that honey. It's going to be sticking in the cup, and the amount that you weighed to the measure is not going to be the amount that you transfer to the actual vessel. And you may be saying, well, wait a second, how does this work when you start to scale up? Well, there are actual scales that you can load a large tote or a large barrel or a large mixing vessel on, and you move it on there with a pallet truck or with a forklift to be able to weigh the quantity of product. And in other cases, some of the larger mixing devices will have online scales that are weighing as the material is being deposited into the hopper that you're working from. But think strategically. Can you weigh directly? You likely did this in your baking class where Initially, you would start and you'd put things into mise en place bowls, and then you realize, wait a second, as I'm getting better at weighing, I can weigh it directly to the vessel and weigh accurately, and then I have less things that I need to wash. And you're also going to not have that same yield loss every time you're putting in a mise en place container. Then you also need to think about weight as purchased versus weight as prepared. So for example, if you're buying bananas, you've likely bought bananas at the grocery store, and you're buying them by the pound or buying them by the kilogram. And when you're using that banana, you are not using the whole banana. You are using the banana as prepared. So we have an as purchase and we have an as prepared weight. And so you really need to be thinking deliberately about when you are buying a product that has trim. So maybe it's onions, maybe it's strawberries that need to have the hulls removed, maybe it's meat where you need to be removing bone or gristle. You need to think about the as purchased weight versus the as prepared weight. And in some cases, you may have to do a back calculation. We'll talk about more about doing yield calculations. But for now, I want you to be really aware that you're going to do as prepared weight when developing your recipes. So make sure that you're paying attention, though, as a product developer, to the as purchased weight and the price of that product as purchased versus the price of the product as prepared. If you're working with really tiny ingredients, think about maybe your baking class where you may have been using baking soda or yeast or salt or certain spices. You may be working in really tiny quantities. As you're doing more technical product development, you may be starting to add additives and preservatives to the food products as well. And you may be at the bench scale be working in milligrams. And so in many cases, people will have an analytical balance, and for more informal or small scale product development teams, they will often get a jewelry scale. And these are readily available online, and they do weigh out into milligram quantities. Again, a larger, good quality analytical balance, you're looking at several hundred to several $1,000s. But if you are in an R&D center where you are needing to have that level of accuracy, an analytical balance makes sense. You have to take care of it, though, and you can't treat it as badly as the cheap scales that you get from Canadian Tire. For liquid ingredients, if you're doing very small quantities of liquid ingredients, such as flavoring extracts or certain additives, you may be pipetting. And I believe you did pipetting with Sunan in your chemistry class. It's a more accurate way to get that repeatable volume. I know oftentimes I think of some of the beverage product development projects that I've worked on, and people will say, well, I'm a bartender, I've been making this beverage, and we'll go in and watch them make that beverage to figure out how to scale it, and they'll be adding a splash of this and a drop of that, and a drop could be all sorts of different sizes, and so it's better to pipette and then also weigh that final formulation as well. You do want to keep track of your decimal points, and so I have two scales in this image here. I've got a scale here with 0.00 or 2 decimal points. And down here I've got a scale with 3 decimal points. So as many decimal points as your scale is going to provide, I'm going to highly recommend that you keep all of those decimal points, because as you scale up your recipe, again, imagine that smoothie. You're making it, you're making 1 or 2 servings for you at the bench scale, as we say, and testing your recipes to scale up. The moment that you scale up that recipe, those fractions of decimals make a big, huge difference. And so you do need to be really aware about what those fractions of decimals are going to mean. If you were working on a product and for some reason the formulation was off, you could be losing a lot of product, or you could have a wide variety of different issues. You make one smoothie and the decimal doesn't really make sense, but now you're making, let's say, 100,000 smoothies. A decimal now is hundreds, if not thousands, of kilos. So you do need to be really aware of that. Oh, here's our friend Salt Bay, and he is sprinkling things just randomly. And I can't stress this enough. As you are going through your product development, you can't just go in and throw spices at stuff. And I realize he's an entertainer, but I'm sure you have worked with chefs who love to just improvise and just grab things from containers and put a dash of this and a sprinkle of that and taste it and then go back at it, and you have no idea how much ingredient you have been weighing into that product. And there are some little tricks that you can do. So, for example, I did a project a few years back where we were working with a chef, a extremely reputable local chef who wanted to commercialize one of his recipes. And we said, you know what we're going to do is we're going to come in and we're going to watch you make this recipe. We're going to document the heck out of this whole process and just watch everything. But before we come in, we're going to weigh everything, that all of your raw ingredients that you want to work from. And so we had mise en place containers, and we knew what the starting weight was on those, and then we knew what the finished weight was. So we could use that as part of our guess on how much ingredient. But at different times during the process, we were able to also grab the pan and say, okay, we're going to weigh the pan and see what the changes were. Challenge was, in that pan we were also losing moisture, and so it was difficult to exactly accurately know how much change was going on. But you can do some fun little tricks of the trade by weighing out different ingredients as you're going along. Oh, what happens if you spill? And this inevitably happens. I have developed a lot of products, and I've worked with a lot of teams, and I've worked with a lot of students, and at some point you're going to make a mistake, or you're going to forget an ingredient. And honestly, when you're in the R&D stage, it is far less costly to start that recipe again from the beginning and do it properly, especially if you're documenting and needing to collect all that data. You don't want to just go about and say, oh, you know what, let's just fudge the numbers today because I made a mistake or I forgot an ingredient. I can't stress this enough that you don't want to amplify those ingredients. I think of the game of playing telephone. I'm sure you played this game as a child where everyone sits in a line and one person has the idea at the beginning, and then they pass that message on to the next person, and they pass the message on to the next person by whispering in each other's ears. If you have a mistake at this stage and somehow it gets passed on to the next stage, the error gets amplified and amplified and amplified, and by the time it gets out to manufacturing, it can be a really huge problem. And so I can't stress this enough. If you make a mistake, life happens. Things happen. People spill. People forget. People get distracted. It happens. Start again. It doesn't make sense to amplify a mistake in the process. Keep notes. I can't stress this enough too. You'll want to keep a notebook or keep a running spreadsheet. Some people prefer to keep their data collection in a computer. I personally am one of those people. I've just happened to have my office flooded and trashed under a few different circumstances, but having my documents in a management system and a cloud drive online meant that I didn't lose any of my documents. So do find a data collection method that works really well for you. In my class, I am very open to you using your computer or using a lab notebook. Main thing is that you are keeping accurate notes as you're going along. And so let's say, for example, I've given you a recipe and I say I want 100 grams of this and 200 grams of that and 300 grams of that in your formula. And as you are going about it, you've now weighed out 102 grams and 198 grams of this and 304 grams of that. Don't fudge your numbers. We'll talk at a later point about when you need to be accurate versus when you can have a bit of space for improvising in terms of analytical chemistry. But in the case of R&D, don't fake your numbers. If, let's say, for example, we told you here's the recipe you should be following or the formula you should be following, put the numbers in accurately so that if you found that it worked really well, then you can repeat that. Keeping documentation means that you can repeat something if it works really well, or you can iterate. Iterate is a great word, and you'll hear me say this a lot. If it had some good attributes, but there were other things you could improve, you can iterate. And so you can make another version with appropriate strategic changes to make your product better. Oh, this one's a little bit wordy slide here. But if you're working on beverages or other liquid products, you are likely going to be doing your initial formulation work by weight, but you may need to know the volume on that product and the ingredients as you're going along. And the image that's there, you may be saying, well, that's a volumetric flask. Well, it's actually a very specialized type of volumetric flask called a picnometer, Pyncometer, picnometer. And it is used specifically for measuring the density of liquids. So you fill it up just like it was a volumetric flask, but then it's got this little capillary up at the top, and it will you have to do it at a very specific temperature, and usually the picnometers are calibrated to a temperature, and then you know that as soon as it's hit the very, very top of that and you wipe it clean with a Kim wipe, that is going to be exactly 25 milliliters. And then you can weigh that on an analytical balance, and that will tell you the grams for 25 milliliters, and you can adjust that for grams to 100 mils. Or you can, in some cases, you will have specific gravity, which is based off of 1.00, which is with the specific gravity of water. Oh, that's it. So I am actually going to stop this, and I'm going to start a second slideshow, because I actually want to walk you through the process of collecting some data as if we were doing a conversion of a recipe over to a scalable formulation, and then that will link out to one of your next assignments, which is going to be doing it yourself with a recipe that you may be making at home. I always joke with the students that in this class, it's not about your cooking skills, it's about your paperwork and your documentation and your ability to manage all of the R&D process, the research and development process, that's more important to me. You have some really amazing teachers who know how to cook inside and out, and they can cook circles around me, but my specialty is all about the process of product development, and we'll talk about what are the industry practices. And so I joke and say to the students, you could make me flour and water sludge, and you could get a great mark in this class, because if you documented that flour and water sludge really, really well and showed me good, accurate documentation, you could do a great mark. So I'm going to stop here, and we will have a part 2 to this slideshow in just a moment.